Okay, let's go ahead and continue number 2. So remember, this was our recurrence relation that we obtained in the last video. So now, again, the goal is to find these coefficients, and so let's explore this pattern. Let's see, if there is a pattern, which there usually is, and then hopefully find well, we want to rewrite that power series in terms of familiar power series that we know already. Okay, so this is the idea. So I'm going to start with n equals 0, right, because my original series started at 0. So if n is equal to 0, well, that just means I'm going to plug in 0 for this guy, right, and 0 for this guy. So I have C0 plus 1, or C1, which is 4C0, or C0, plus, well, over 0 plus 1, which is 1. And then this just simplifies to 4C0. Okay, so C1, right, is equal to 4C1. What if n is equal to 1? Okay, so again, I'm going to substitute 0 or 1 for n. So I have C1 plus 1, which is C2. And then I have 4C1 over 1 plus 1, so that's 2. And then we have, well, that's just 2C1, but we know what's, well, just to be consistent here, I'm going to go work, well, I'm going to work vertically when I'm substituting another expression. So here, okay, so this guy, right, that's just a big 2. So I have 2 C1, but what is C1? Well, C1 is right there, so times 4 C0. So I conclude that C2 is 8 C0. Okay, so that's one relationship. Well, another one. What if n is 2? Well, if n is 2, then I have, again, just going back, so it's C2 plus 1, or C3, times 4Cn, or in this case C2, over 2 plus 1, that's 3. Okay, so I have 4/3 C2, but I want to write my Cn's in terms of C0. So I have 4/3, but what is C2? Right, well, C2 is right here. That's just 8 C0. And then I have, right, this is just, what I have, 32 over 3 C0. So that's what C3 is. And let's go ahead and do one more. So n equals 3. So I get C 3 plus 1, so that's 4. And C4 equals 4Cn n plus 1. So 4Cn n plus 1, so that's just 4. Notice that's just 1. Okay, so C3 is equal to C4, but C3, we figured out that was 32/3 C0. Okay, so here is, I mean, we found some relationships. And again, you can keep going. I mean, I would do at least 3 or 4. But if you're having trouble seeing the pattern, then feel free to do a couple more, find more data. Okay, so I'm going to go ahead and rewrite these guys, maybe on the side. Maybe sometimes it's easier to see the pattern here. So C1 is 4C0, C2 is 8C0, C3 is 32/3 C0, C4 is 32/3 C0 again, and again, if you want to find C5 and so forth. So here are my CNs, right? These guys are my CNs. So what was our goal? I mean, our goal is to find a solution to this differential equation. And remember, we assumed that it was a power series solution. So we have, I'm just rewriting my y. So we have Cn x to the n, right? But again, what does this mean? This is just C0 x to the 0, which is 1. Or in other words, C0 plus C1x plus C2x squared plus C3x cubed plus ... right? It's an infinite series. Okay, so we have this command, and so let's go ahead and input our CNs in terms of C0. So C0 plus, okay, what was our C1, C2, and C3? Right, so maybe let's highlight those. So they're right here. Okay, so C1 is 4C0. So that's 4C0 x plus C2 is 8C0 x squared plus C3 is 32 thirds C0. That's a C0 parentheses x cubed, and I don't like how that looks. So let's see, C0 plus C4, and which was a 32 thirds, again, C0, all of that, right, x to the 4th power, and again, I can just write dot, dot, dot. Okay, so we have this infinite sum, and I want you to notice that we can factor out a greatest common factor, which is going to be very common to do. So we can take out a C0. So if we take out C0, I'm left with the following. 32 thirds x cubed plus, again, 32 thirds x to the 4th plus dot, dot, dot. And let me add a parentheses here. Okay, so this is, I think, the most challenging part. The next part, and again, this is with practice, the more problems you do, the better you get at kind of discovering the patterns. And that's what mathematics is, really, just discovering these patterns. So we want to look at this infinite power series, and we want to ask ourselves, does this remind us of familiar power series? So specifically the ones on, I believe it was page 195. Is that 195? Yes, 195. And I mean, it doesn't look like any of them exactly, but it has to be one of them because the instruction says to rewrite in terms of familiar one. So again, a challenging part. Well, I mean, you look at 4, I'm thinking, maybe 2 squared, 8 is 2 cubed, this is 2 to the 5th divided by 3, 2 to the 5th divided by 3. And if you play with it, I mean, it actually doesn't resemble any of these guys, but one thing you want to notice is when you're working out these CNs, notice that, right, the general formula was you were multiplying by 4, right? 4 times 2 gave you that 8, right? 8 times 4 gave you that 32. So that factor of 4 kind of gives you a hint of how you can rewrite this. And this actually ends up becoming, okay, so I'm going to go ahead and write, so I have 1, so I know 1 is, I want to have a 4 in here. 4, so 4 to the 0 is the same thing as 1. Okay, I'm going to divide by 0 factorial. I'm going to tell you why in just a bit. Plus, okay, the next one, 4x, that's the same thing as 4 to the 1st power divided by 1 factorial plus 8, well, your 8x squared. Okay, I'm going to write 4 squared over 2 factorial plus 4 cubed over 3 factorial plus 4 to the 4th over 4 factorial plus dot, 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 and then we have our, well, I didn't write our x's in here, and I should have written our x's, so maybe we'll write it out here. Okay, so how did I know that this was the power series? I've been doing these problems for a long time, so I can see the pattern. But if you want to see if it actually works out, okay, anything to the 0 is 1, right? So C0, So that's 1 over 0 factorial is 1. Okay, so that's 1. Plus 4, well, 1 factorial, that's just 4 over 1, which is 4. Okay, 4 squared, that's 4 times 4, which is our 16, right, over 2. And 16 halves is really 8, right? And similarly, I get, right, 4 to the 4th, okay, that's 4 times 4 times 4 times 4 over 4 factorial, which is 4, 3, 2, 1. And, right, if that's gone, let's see, I can do 464. Oh, we can do these guys. Let's see, I have 16 times 2, which is 32 over 3, and that's exactly what I have right here. So, I mean, this one involves factorials, and actually, if you want to write your general Cn, okay, your general Cn is going to be 4 to the n C naught over n factorial. And again, this comes with practice. Don't stress about it if this is your first time doing this and you're not catching the pattern. That's fine. It's just practice. Okay, so that's our, let me rewrite this a little bit. Well, we have it here actually. So what does this remind you of, this one right here? Well, this definitely looks like, I'm going to go ahead and write e to the x, just so you can see this. So e to the x is the same thing as, okay, so short term, or shorthand, x to the n over n factorial, right? We have a power, we have powers, we have factorial, we have factorials, and this is just 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. Okay, well, this is not exactly e to the x, right? I have some 4's in here, so it looks like this might be e to the 4x. So instead of x, I can rewrite this as, so n equals 0 to infinity, so maybe I have 4x to the n over n factorial, or 1 plus, again, 4x plus 4x squared over 2 factorial plus 4x cubed over 3 factorial, and so forth. So I have my, right, instead of my x's, I have 4x. And we can even, right, rewrite this a little bit nicer. So let's say 1 plus, I can say 4 squared, well, actually, that one's not 4 squared. The next one is, this is 4, let's see, x over 1 factorial plus 4 squared x squared, right, if I multiply in my x term, over 2 factorial plus 4 cubed x cubed over 3 factorial plus 4 to the 4th x to the 4th over 4 factorial plus dot dot dot. So again, I know this looks very similar. It's familiar to e to the x because I have, right, x to some power over factorial. Well, x to some power, x to some power, x to some power, and then I have my factorials, which are really the same number here. The only difference is that 4. So I can rewrite my power series, and I forgot my Cn, my final, let's see, my Cn final solution. So y of x equals c naught times, well, all of this is really e to the 4x. And I didn't really have to write that big parentheses. Okay, so there's my power series in terms of a familiar function, which is e to the x. And I'm actually going to stop right here and do find the radius of convergence in the next video because I have 20 seconds left is my limit for the videos. So I will see you in the next video.